Thanks to the ISBSG for this opportunity to speak in the conference. And this is the second time I'm speaking in the ISBSG conference. And the topic I'm going to be speaking about is how to benchmark software productivity and quality in the era of large language model code generation and using low code and no code platforms to build applications. Okay, that's the brief bio. You can look it up later. Okay, and if you see software development methodologies have existed since the 1960s, and they've slowly evolved to what they are right now. And it just starts from simple methodologies like code and fix, structured programming, formal methods, to more defined software development methodologies like waterfall, uh, Capgemini, SDM, prototyping, to structured systems analysis and design methodology, V model, then object-oriented programming, rapid application development, Scrum, rational unified process, and to the 2000s where you had Agile, and 2010s we have like SAFE, LESS, all these methodologies, to right now where there is a proliferation or a prevalence of no-code and low-code platforms, and also code generation via large language models. That is also in use. So as and when these methodologies have evolved over the last 60 years, also the estimation models have also evolved, and they've also, estimation models have also basically changed. And what we had was simple expert judgment using WBS. Then we had statistical methods like regression models, to more formal methods like COCOMO that used historical data and function points and to the use of COCOMO2 and DevOps metrics, agile estimation, and so the estimation models also have changed. They've changed considerably based on the current day methodology. Okay, so in that scenario, what we have is when we are using low code and no code platforms, or when we are going to do code generation via large language models, our current ways to measure or estimate software, especially the matrices, may not be valid. For example, you may not be able to say size and lines of code or function points. Okay, you may not be able to say effort like human effort, because here there is something else. It depends on how you configure your components in low code, no code platforms, or in LLMs. It depends upon how good you are with the prompt engineering and so on and so forth. So here there are just some simple advantages and disadvantages of using low code, no code platforms and LLMs. And the simple advantages are it's rapid prototyping, the use of non-technical developers like citizen developers, okay, and easy integration with different applications, okay. And there are also the disadvantages is customization is what the vendor offers. There are platform capabilities. For example, you may not be able to build and export to MS Excel from the database. The platform may simply not allow it, okay. Or you may not be able to just build a highly secure web application like internet banking, or something like a healthcare application that's got a lot of compliances like HIPAA compliances and so on and so forth. So such kind of things your LCNC platforms may not be able to build. And like many speakers before have said, that it just increases the productivity. Like, for example, supposing it takes the developer, say, 2 pages to write a simple web page, your LLM may just generate it within, say, just a few seconds. So that's how the productivity gets improved. The productivity is really very high when you use LLMs. And in the case of LCNC, it's all pre-configured, easy visual drag and drop interfaces where you just pull the interfaces and then configure your components, configure your application. But having said that, there are also a lot of disadvantages like hallucinations, LLM hallucination, and code quality. It needs to be reviewed by a human expert. Okay, and it's not reliable. Code generated by LLMs is not reliable, and so on and so forth. The only tangible advantage that LLMs, code generation or LLMs offer over traditional programming development is that they're very, very highly productive. It's like you can even say it's like 1,000 times more productive than a human developer. Okay, so here is a simple chart. Uh, here uh, Here is a simple chart. So here, what I've just shown is that uh, when your complexity is very low, for example, if it's just a simple web page, okay, and then there's a comparison that I've made between the skilled human teams and automation via LCNC and LLMs. So if you see when the complexity of these tasks is very low, that time the LCNC platforms it or code generation via LLMs, it tends to uh, just one second, please. It tends to just one second. Okay. So if you see here, when the complexity of the task is very low, so automation and LLMs are much better, and the problem-solving efficiency is very high. The error rates are very low. There's no human errors, nothing, no unforced or forced errors, and the skilled human teams will just perform on a much lower efficiency scale than LLMs or automation. But then, if you have some complex requirements or complex solutions, there are two things. One is the problem can be complex, and the solution can be complex or easy. Okay? So if your problem is complex, if the requirement is very complex or it's large sized, okay, I have a very big application with 500 screens or 500 tables, for example. It's a huge database. Then definitely human skill teams will perform better than your low code, no code platforms or any other form of code generation using LLMs or applications that are configured using LCNC. They will definitely it will definitely perform. The human teams will perform much better than any kind of code generation once the complexity of the complexity is high or when the size is very big. For example, if you have an internet banking application or an online travel reservation web application, okay, I'm sure that LCNC platforms cannot match a human expert team. There is a summit. So you always need to have a human expert team on the site to review the code that is generated and make corrections and so on and so forth. So here it's just a small table that I've put. Like these are traditional, typical business applications. And here, if you have a simple stock tracker that you use in a, say, grocery store, the success rate using LCNC may be very high. It will be medium for LLMs because it has to have a code review. The LLMs do hallucinate, and then they do produce erroneous outputs. And sometimes they don't respond. They have prompt insensitivity. They don't respond to prompts, and so there is a human reviewer that is necessary to always review and correct the code if necessary. But that may not be the case with LCNC platforms. LCNC platforms will work very well if the complexity is low or medium. But if the complexity of the requirements are very high, or if the solution complexity is also very high, and that time even the LCNC platforms will not be able to do it so efficiently. For example, this is a simple table where I've just shown all the commonly used business applications. Like if it's a stock tracker and that's used in a grocery store, the LCNC will just be very, very efficient, and so will the human team be. But if it's say an airline ticketing system, and that time the success rate using say a large language model will be very, very low, and the airline ticketing system. LCNC platform also may have a lot of capabilities that will not be addressed, real-time data processing capabilities that may not be addressed. Okay. Similar with the healthcare application. Okay. So this is just a simple chart that shows that automation and LLMs will perform well when the human skill and team knowledge are low or for very simple requirements. But for more complex tasks and say real time, you need a lot of security checks. If you're if there needs to be vulnerability assessment and so on and so forth, your LLMs and your LCNC platforms will not be so effective as a human skill team. The human skill team will have all the knowledge and all the creativity they will definitely have, and they'll also have the creativity to. They'll also have the knowledge to create new things or to discover and to invent. And the only tangible advantage of using LLM for code generation would be to gain a significant increase in productivity of uh, repeatable tasks. Okay, so I've just captured that in this small graph to say that the human team it'll outperform the LLMs when the requirements are complex or when the solution is complex. When you need to write complex code, that time the human team will definitely outperform, and it will be very good. The LLMs and LCNC will be very good for lower complexity tasks, but where productivity gain is a significant advantage. Okay, so here if you see now, how do we estimate applications built using LCNC platforms? Okay, because we don't have lines of code, you don't have functions, you don't have modules, you don't have tables, you don't have databases, you don't have function points. Basically, you don't have everything that you had in the traditional software engineering. You don't have anything in the LCNC models. So they're all pre-built components, okay? Connectors, integrators, and now the citizen developers can also take part in addition to the technical developers, okay? So it all depends upon how familiar you are with the platform so that you can just work with it with ease. So here on the right hand side, I have shown a simple app generator. It's an app generator. It's a very popular app generator, and here there's a screen that's generated by the app generator. So in order to use this, the developer must be like must be proficient with the platform. Okay, so that is one of the factors that you will go to estimate what is the effort that is required to build some app automatically. This is a no-code platform. So one of the parameters will be how familiar the developer is to and how comfortable or how proficient or well versed with this platform he is, so that he can just generate it easily. Okay, so your traditional matrices uh, will not work in case of LCNC. So we have to design new matrices, and your traditional methods of estimating effort or calculating computing effort, measuring effort also will not be valid. So instead of say defining productivity as number of function points per hour or PDR as one by function point, you need to design something that uses like components, the connectors and integrators, and what are the skill levels, whether they're citizens who are participating in the in the app generation process, and what kind of additional validations that you're going to write into your LCNC platform. You need to LCNC platforms also just don't work just like that. You need many times they need to have custom validations that are written, and and so there's sometimes there are also a lot of external connections that your LCNC needs to make. For example, enterprise application integration. Or supposing I have a customer relations management and I'm just using an LCNC platform to configure, and say the vendor or my customer needs to be integrated with SAP so that they can do some enterprise application integration that is available in most of the modern commercial CRMs, for example. will the LCNC platform be able to build it? It may not be able to build it. In that case, you need to have additional effort for customization. So your basic models, your estimation models, like it has to just factor whether what is the extent of customization that I need to do in order to just uh, uh, record the effort. So there is some amount that you can achieve easily by automation, but there's some amount that you cannot achieve by automation. You have to resort to manual coding. So your effort estimation models has to take into account all this, and that's what I've just captured here. So here you see the same. You're developing these estimation models for uh, code generated using LLMs. On the left-hand side, there is a simple page that was generated using a large language model, and there were nearly 15 to 20 prompt revisions, and it got developed within, say, quarter a day or half a day. And you see the navigation control that the LLM has generated is very, very poor, and it hallucinated when there was a prompt to just to improve the navigation control and to just make it into a rich style, okay, and make it pleasing to the eye, and it didn't understand it, and it just hallucinated. And this was the best output that it produced on the left-hand side. Here, the same page was improved by a human expert, and it took him like nearly 3 days to improve it. You see, it's like it looks much better, and much more. The usability factors are considered, and it looks much better. But then it's gone back to the 3 days. Okay, so we couldn't just simply use the LLM generated page just like that. So had we estimated, saying that based on the prompt revisions and how productive the LLMs are, saying that this page is just going to take just say 3 hours to do because LLMs are very, very highly productive, and then we'd be wrong because it's taken 3 more days to just correct the output, and then restore it to something that can be used. Okay, so basically your estimation models, it has to consider such things like what is the likelihood that the output that the LLM generated is not usable, and it's got errors, and with that, what is the percentage of effort that a human developer will need to spend to just correct the page or make it work correctly? So your basic effort estimation models has to be combination. It has to be based on human factors and also how good the LLM is, efficient the LLM is. Okay. So in the future, we will need such matrices for recording the effort, because the paradigm of software development, the trend is changing to more automated software development. But at the current moment, there are some bottlenecks and loopholes. And okay, so the matrices that we use for traditional software engineering, they have to be like modified uh, to choose like software engineering cycles that are based on LLMs or LCNC platforms. So here, if you see the ISB SG data repository matrices, okay, they have a lot of measurements on PDR, cost efficiency, delivery speed, process quality, and value delivered. Sorry, I'll just go through it a bit quickly because I'm running behind on time. And that will be uh, the same PDR, how you measure in your traditional software engineering cycle. So here, when I just extend that to measure applications generated using LCNC platform, so this is what I'll possibly need. Apps for modules developed, time to prototype, iteration time cycle, user acceptance rate, percentage of features accepted without rework, and what is the developer effort, or what is the citizen developer participation rate? Can a normal citizen use an NCNC platform and configure a simple application by just working from home? Can a retired person, for example, build a website that gives you help resources for senior citizens? Will he be able to do it using an LCNC platform, or will he be able to do it using a large language model to generate the code? So, in which case, your project delivery rate, okay, what we typically measure as 1 by the inverse of function points by effort, okay. So it has to be adapted to uh, applications configured using the LCNC platforms. Like apps per module reports, time to prototype, iteration time cycle, user acceptance rate. So these are the common matrices that I've listed. Similarly, if you want to measure PDR in an LLM assisted development, what could be the metric that you will measure? Prompt to output time, post generation fixed time. So how long does it take the human developer to kind of just fix outputs from the LLM? So how many reusable code blocks per day? What is the test coverage, okay, of the generated code? All of you will know that there are test coverages, code coverage and test coverages, the quality assurance people use for measuring traditional software engineering. But in this case here, the LLMs may produce incorrect output. And for example, as a simple experiment, if you generate a page using an LLM, say ChatGPT, and then you tell Perplexity dot AI to just review the code that's generated by ChatGPT, Perplexity AI will give you 100 improvement points. Why is that so? Does it mean that the code generated by ChatGPT is not correct, or is it just writing whatever it wants to write, just to present some points? We really don't know. But some of those points may be valid. So that means the code generated by LLMs may not be perfect. So it needs to be reviewed. And so basically, your metrics, your matrices, whatever you measure in your traditional software engineering, has to be adopted to LCNC. So here it has to be adopted. So similarly, there are matrices like cost efficiency that ISBSG has extensively measured. And so here, how they define cost efficiency is output delivered by total cost incurred. And here, if you see, you may just need to just change it a little bit and put total dev cost by number of delivered modules, percentage reduction in dev effort, okay, and percentage contribution by, okay, this once again, and okay, drop and rework due to standardized components. So these are all some matrices that you can just design. Possibly a lot of human experts also can be involved in it, and design what are the appropriate matrices that you'll use if you're using LCNC, and how do you define cost efficiency for an application that's been configured mainly using custom built connectors and components using an LCNC platform. Okay, so and so these are the metrics, some of the metrics that I've put matrices that I've put down. So similarly, if you see LLM, so what is the cost per prompt output? So what is the rework? Okay, what is the fixed cost post generation? And see, and what are the comparative highlights is primary cost saving and reduced dev time by visual tooling. And okay, these are all so what is the cost timing? Cost saving is development time reduces, reduced coding effort in the case of LLMs, platform subscriptions, okay, and rework cost will be low, and it'll be it can be moderate to high in case of LLMs. And so basically, what I'm trying to say is these matrices that we are measuring, that ISBSG has measured extensively, it needs to be modified a little bit, and then you have to capture these measurements again when LLMs are used, or LCNC platforms are used, as the case may be. Okay? So this is another metric that we use very commonly, delivery speed. So time to deliver a functional output. And so here the metric could be time to prototype, time to deploy, what is the iteration turnaround, what is the review for QA time, and then it's just a comparative chart on the productivity, on how these measurements will look when you use LCNC or LLM. And similarly here, so that's the key metrics, like delivery speed, what's the time to prototype, and what is the time to deploy? What is the time to just iterate it quickly and fix if there is a issue that's been identified by a reviewer? And okay, and for example, if there's bad code quality, that's it's just somebody has identified. So how quickly are you going to fix it? And um, what is the review efficiency, or what is the uh, what does what, like especially in LCNC platforms, the code is just abstracted. It's abstracted into the platform. So we really don't know, because it's all vendor based and it's not open source for people to just kind of just uh, 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 investigate it thoroughly. It's all hidden inside all the platforms. So once you just drag and drop a component and say you're using a payment gateway, and then there has to be, supposing you configure a payment gateway using an LCNC platform, there has to be a thorough check of the vulnerabilities. Okay, there are a lot of vulnerabilities needs assessment itself is a huge separate topic where where somebody can just hack your application through the internet, or there can be some Trojan virus that's there on your PC that just reads your sensitive banking information, and then send it to some other remote location. There are a lot of these hacks that are possible. So if you have a traditional software engineering methodology, and there are all these service providers that provide custom integrations for like APIs, they provide for the payment gateways to just be integrated into your website. Okay. And if you do the same thing with these LCNC platforms, is it secure? We really don't know whether it's secure or not. So because you don't know, it's just a black box. So you have to employ techniques like from black box techniques, and possibly testing, black box testing, in which case you have to do a lot of functional tests and observe the output in all kind of cases, whether there's a security issue that's there that's hidden in the code. Because and black box testing is because you don't know the test cases. It'll definitely take more time. So basically, your testing, in that case, your software metric to measure the test effort, it has to account for that. So because if your function, if the lines of code is just like it's visible to everybody, and I'm sure there's a lot of these human experts will immediately find out that there's a defect here, and there's this defect that's going to just cause some harm. But that's not the case in LCNC. It's all hidden inside, abstracted away. And so you have to use special techniques to test it, in which case the testing effort cannot be estimated using usual methodology. It cannot be estimated. And so that is one thing. And as speakers before have pointed out, LLM definitely has its issues of hallucinating and producing erroneous outputs. So it takes more time to fix. It may take 10 times more time to fix the code that is generated by the LLM, overriding the significant advantage of code generation, where it's very, very fast. And so traditionally, if you want to just estimate, say if you have a customer and then we are providing our data set, ISB SG is providing its data set to customers, and then they have LLM, say a chat box that just does this code generation. So the estimation models should also consider like whether the speaker before me said it has to be deterministic, and that's a very, very brilliant point that he had made. So all that in steady state, you have to observe, and you have to record all the measurements in steady state. Also, statistically validate uh, that your estimations will provide correct outputs to the models will provide correct outputs. So all this you need to just we need to consider. So basically, in the evolving scenario where the landscape of software development is changing, so the metrics also have to be adapted. So here is another. These are the two metrics that ISBSG extensively uses: process and value metrics. So this is how it will look when process quality, when you say defects per thousand functional signs of units delivered. In LCNC platforms, it may be defects per n number of visual modules, screens, workflows, and defects are errors traceable to vendor updates or templates, okay, and then the workflow rigidity score, okay, and here the LLM assisted the same process quality could be defects per n number of lines of generated code or defects per, and what is the reducing number of defects per prompt, whether the LLM is hallucinating or whether it's sensitive to the prompts. So you can just repeatedly iterate with the LLM and say that please improve this or just please fix this, and finally it may not be able to do that. Okay, and it may introduce a defect. So you may also need to measure like what is the incidence of defect occurrence as per the number of prompts. Okay, if it increases. Finally, here what is the value delivered? So these are the matrices that I've shown as a sample, how it can be adapted basically to uh, applications that are configured using LCNC or code that is generated using LLM. So here, these are just comparative metrics. So if you see a size LOC, which we readily measure in LCNC platforms, it's visual logic blocks, script per configuration lines. And here in this, just a second, please. And here in the LLM generated, it's like generated code lines. And similarly for size, you readily measure now using function points or user stories. And for LCNC platforms, what are the number of workflow pages? What are the number of components? Okay. And for LLMs, it can be like what are the functions totally generated, and per prompt, what is the effort? And there is productivity, SE effort, like schedule. And similarly, how do we measure defect density comparatively here? What are the bugs per app? Just a second. It's just, okay. What are the so here uh, we have all these matrices like defect density, maintainability, customization, security. Okay, this as far as I think like security aspects is very, very important, especially when you're generating e-commerce or banking applications, or for example, healthcare that need a lot of HIPAA compliances and so on and so forth. So here, this is a traditional SC metric like cyclometric complexity. Okay, so how will cyclometric uh, metric complexity be measured if you generate code using your LLM? So it's like code clarity or ease of regeneration. Okay, and for LCNC, how easy is it to just change the built-in components or just configure it? Okay, and okay, so these are just your normal matrices that you measure in your traditional software engineering. How it will get altered? How it will get altered if you configure your applications using your LCNC platforms, or if you generate the code using your LLM. So these are just some examples, but then um, so basically the measurements have to just be adapted, and so once you adapt, the estimation methods will not change drastically. You'll still use like machine learning or statistical methods or neural networks or Bayesian inference. And there are so many methods that you'll use. And those methods will not change. But the matrices themselves will have to undergo some kind of refinement. So this is your traditional cycle, like collecting data sets. And if you see here, measure. So here, measurement. So that is what will get altered in the in your latest new generation methodologies of that's what will get altered, like LCNC. Your matrices will get altered, but your estimation techniques will not get altered. So basically, It'll just be historical data, but historical data, instead of just measuring function points, okay, for size, you'll say number of components. Number of components, say, where code is testable, number of components where code cannot be tested. And similarly, if you say testing effort, there are some benchmark studies in the SDLC that testing has to be 40% of the total project development time, say. And then here, you'll say in LCNC, scenario, depending upon the complexity of your applications, you will say that the effort, testing effort, it needs to be 50%, so on and so forth. Okay. So basically, the metric that whatever you need to measure, that will change, but your estimation models that will work on historical data to predict future values or future possibilities, like calibration. Like, for example, if your organization is using historical data, then if they have a different set of surrounding conditions, different from those conditions under during which the measurement was taken, then your model has to be calibrated or fitted to the organization. Okay, so the calibration will just work on historical data, so that will not change. What will change is the matrices, what we measure, what we need to measure, that will need to be adapted. So, and that uh, it depends upon how fast they are adapting to automated code generation and automated configuration of applications. Okay, and so that's what I just wanted to convey. So here it's just a small conclusion that constructing estimation models for LCNC LLM code generation requires moving beyond traditional code-centric metrics. It demands a focus on component configuration, integration complexity in case of LCNC, prompt engineering effort in the case of LLMs, and crucially, what is the human effort that is needed for verification, and do we still need a lot of skilled people, highly knowledgeable people, technical people? Do we still like need to just need them to be standing by, and when you're trying to configure use generated code, and what is the human effort needed for verification, refinement, and testing of AI generated artifacts? So all this in a crux will just go into designing your new matrices. Okay, so thank you very much. I have finished. Uh, Thank you very much. Thanks for the chance to just speak on today's conference. So if you have any questions, I'll just be very happy to answer it.